For any two vectors A and B, give the geometrical representation of the relation the magnitude of the sum of the vectors equals the magnitude of the difference of the two vectors. Okay, let's try to understand the problem first. So what we'll do, we'll consider two vectors, vector A and vector B. So we have considered two arbitrary vectors, vector A and vector B. Now using these two vectors, what we'll do, we'll find out the sum A plus B vector, and we'll also find out the difference A minus B vector. So here what we'll do, we'll begin by first displacing the vector A to a new location without changing its direction and magnitude. Next, we will also displace the vector B, but we'll be displacing in a way such that the terminal point of vector A coincides with the initial point of vector B. Now when doing so, we can easily add the two vectors, vector A with vector B, using the triangle law of vector addition. All we have to do is, since we started out from the initial point of A and ended up with the terminal point of B, so we will be joining the initial point of vector A and the terminal point of vector B with a straight line, and the vector going from one point to the other, from the initial point to the terminal point, and that's going to give us the vector sum of A and B. So we have vector A added to vector B using the triangle law of vector addition. Next, we will try to find out the difference of the two vectors, A vector minus B vector. So that means we need negative B vector. Negative B vector means take vector B and multiply it with -1, and that is going to give us negative B vector. All it does is changes the direction of the vector B without changing its magnitude. So here we have vector negative B vector. So what we'll do, to find out A vector minus B vector, we will coincide the terminal point of vector A with the initial point of negative B vector. Let's do that. Now that we have negative B vector as well, we can add A vector to negative B vector to get A vector minus B vector. All we have to do is take the initial point of vector A and draw a straight line joining the terminal point of negative B vector. Now we have the vector A, we have the vector B, we have A vector added to B vector as well as A vector minus B vector. Let's try to combine all the four vectors, and this is going to give us a parallelogram. Now in order to construct this particular parallelogram, what I have done here is coincide the initial point of the two vectors A and B. Then we displace the vector A vector added to B vector and A vector minus B vector, and those are going to form the diagonals of the given parallelogram. So let's name this parallelogram as A, B, C, D. Now here we have AB, so this corresponds to the vector A. Then we have AD vector, so AD vector is going to correspond to the vector B. Then we have the diagonals AC vector, so AC vector is going to be A vector added to B vector, and then we have DB vector. So DB vector will be the vector A vector minus B vector. Fine. But it is given in the problem that the magnitude of the sum of the two vectors A and B equals the magnitude of the difference of the two vectors. So since the magnitudes are equal, that means AC will be equals to DB. The diagonals are equal, and we know that whenever the diagonals of a parallelogram equal, that simply tells us that ABCD must be a rectangle. And if ABCD is a rectangle, that means the sides are perpendicular to each other, or in other words, we can say that A vector must be perpendicular to the vector B. So this is what we can say about the vector A and B. If this particular relation holds true, that means the magnitude of the sum of the two vectors equals the magnitude of the difference of the two vectors.